Welcome to the first flip lesson on the A2 chemistry topic of transition metals. During the lesson you'll need to have a periodic table handy and be ready to make notes. So if you need to pause the video now, do so and go and get your data sheet, a pen, paper and the note framework for the lesson if you're using it. In today's lesson we're going to recap redox reactions from AS chemistry and explain the key terms redox, oxidation, reduction, oxidizing agent and reducing agent. By the end of the lesson you should also be able to combine half equations to write an overall chemical equation involving both oxidation and reduction. So let's recap some key terms. Oxidation is the loss of electrons and an increase in oxidation number. Reduction is gain of electrons and a decrease in oxidation number. In a redox reaction, both oxidation and reduction take place. The oxidation and reduction can be expressed in terms of changes in the oxidation number. Moving on to oxidizing and reducing agents. An oxidizing agent is something that oxidizes another reactant by taking electrons from it. The oxidizing agent will reduce in oxidation number. A reducing agent is something that reduces another reactant by giving it electrons. The reducing agent will increase in oxidation number. Let's look at a simple example. When zinc is added to copper 2 sulfate solution, the products are copper and zinc sulfate. If we assign oxidation numbers, an element on its own is 0. Copper has a charge of +2, and if oxygen is -2 and there are 4 of them, and the overall compound is neutral, sulfur must have an oxidation number of +6. In the products, copper now has an oxidation number of 0, sulfur and oxygen remain the same, and the zinc now has an oxidation state of +2. So copper has gone from +2 to 0 and has been reduced by gaining 2 electrons. Zinc has gone from 0 to +2 and has been oxidized by losing 2 electrons. You need to be able to write half equations and combine them to form an overall equation. In one half equation something gets reduced and gains electrons, and then the other something gets oxidized and loses electrons. Considering the redox reaction between zinc and copper sulfate, in order to write the two half equations, you must first identify the species that are changing oxidation state. Copper is being reduced by going from +2 to 0, therefore it must gain 2 electrons. This is shown in the half equation on the slide. Cu2 plus 2 electrons reacts to form a copper atom. Zinc is being oxidized by going from 0 to +2. Therefore it must lose 2 electrons, so we put them on the right hand side of the equation. Zinc reacts to form Zn2 plus 2 electrons. Now to combine the two half equations. If you have written your half equations correctly, you should notice the electrons are on opposite sides. The second step is to balance the electrons. In this case there are 2 electrons on each side, so they are already balanced and cancel out in the overall equation. Finally, we need to rewrite the equation without the electrons. Let's look at a second example. Chlorine reacts with iron 2 ions to form iron 3 ions and chloride ions. Step 1. Identify the species changing oxidation state. Chlorine gas and iron 2 are both changing in oxidation states. Chlorine is going from Cl2 to Cl-, so a change from 0 to -1. So electrons must be added to the left-hand side. As each chlorine atom gains an electron, we need 2 electrons. Cl2 plus 2E- goes to 2Cl-. This is a reduction. Fe2 plus reacts to form Fe3 plus. So a change in oxidation number from +2 to +3. So an electron must be added to the right-hand side, and this is an oxidation. Fe2 plus reacts to form Fe3 plus an electron. Step 2 is balancing electrons. In the first half equation, Cl2 reacts to form 2 chloride ions. 2 electrons are gained, and in the second equation, Fe2 plus is losing only 1 electron to go to Fe3 plus. To balance electrons, we therefore need to multiply the second half equation by 2. So we have 2 Fe2 plus reacting to form 2 Fe3 plus 2 electrons. Finally, step 3, cancelling and combining. The electrons on each side cancel out, leaving Cl2 plus 2 Fe2 plus reacting to form 2 Fe3 plus 2 chloride ions. Now it's time for you to have a go yourself. Pause the video and have a go at the example on the slide. The answer is on the following slide. So let's look at the answer. Lead loses 2 electrons to form Pb2+. Silver plus gains 1 electron to go to a silver atom. To balance the electrons, we need to multiply the silver half equation by 2 and then combine, cancelling out the electrons. Moving on to the next level. When balancing half equations, as well as adding electrons, you may need to add water molecules or hydrogen ions or hydroxide ions if the reaction is being carried out under acidic or alkaline conditions. You'll be told this in the question. Let's look how it works in practice. Iron 2 solution reacting with manganate 7 solution, MnO4- ions, in acidic conditions to form a solution of iron 3 ions and Mn2+ ions. To begin with, we need to work out which species change oxidation state. Looking at the manganate 7 ion, manganese has an oxidation number of +7. This is shown in the Roman numerals in the bracket, or you could work it out knowing that oxygen has an oxidation number of -2 and the overall charge on the ion is -1. So iron goes from iron 2 to iron 3. This is a change from +2 to +3, so there is a loss of 1 electron. Manganate 7 goes to manganate 2. This is a reduction from +7 to +2, so there is a gain of 5 electrons. However, the manganate ion contains 4 oxygens, which do not appear on the right-hand side of the equation. And we get told in the question that reaction is carried out under acidic conditions, so there must be hydrogen ions as a reactant. Looking back as to what we are allowed to add to balance half equations, we can add water. We never add oxygen gas, O2, or hydrogen gas, H2. If you need oxygen, you need to add water. We need 4 oxygen atoms on the right, so we add 4 water molecules. Now, there are 8 hydrogens on the right-hand side and none on the left. So we add 8 hydrogen ions to the left-hand side. We know we're on the right track as the question states is in acidic conditions. One final check you can make is to make sure that the charges on each side are equal. Looking at the left, manganate ion has a charge of -1. There are 5 negative electrons and 8 positive hydrogens. This equals +2. On the right-hand side, there is just 1 + 2 manganese ion. Finally, to balancing the electrons, cancelling and combining. We need to multiply the ion equation by 5 so that there are 5 electrons on each side. Combining these equations gives the overall reaction as shown on the slide. Now it's down to you. Have a go at the example on the slide, remembering that there are 2 chromium ions. Pause the video, the answer is on the next slide. During class time, your teacher will be on hand to help you with lots of examples, so don't worry if you found this difficult. Go back through the video again and go over your notes.